Stop.
Two.
One. So I've started.
This is Orekoya Oluwasegun. I'm a freelance mathematics and physics fundamentals tutor. I will appreciate your interest in learning physics this afternoon. And the topic for today is simple harmonic motion. Now, simple harmonic motion. A body undergoes a simple harmonic motion if its motion is periodic. What do you mean by periodic? That means if the motion is repetitive at a constant intervals of what? Time, in such a way that its acceleration A towards equilibrium or rest position is directly proportional to its displacement x from this equilibrium position. Now, this definition is to be explained in this diagram. Let us imagine a particle located at point E on this horizontal line. The horizontal line is a line that represents the displacement vector. Now, anytime this body moves away, that is, it is shifted from this particular rest position called equilibrium position to one side, it will be displayed from that particular initial rest position to a particular displacement x. It has been observed that the proportion of displacement is directly proportional to the acceleration of this particle towards the equilibrium point. Now, there is a particular maximum level of displacement. The maximum displacement of this particle from equilibrium position is called the amplitude A. Now, we can make reference to the simple pendulum bob oscillation. If you look at this pendulum bob that is at rest position here, when the pendulum bob is shifted to an extreme end, it has been displayed. In the equilibrium position that it was before, we discovered that the height to the reference point is 0. Therefore, the potential energy is going to be minimum. At that point, because of the law of conservation of energy can never be created nor destroyed. When the potential energy reaches 0, it will be converted to kinetic energy. So what am I trying to say in essence is that at equilibrium position, the kinetic energy is maximum while the potential energy is minimum. But when the bulb has been shifted to the extreme end, that has been positioned away from the equal position at the maximum point, it has been observed that the potential energy becomes maximum and the kinetic energy becomes what? Minimum. So the opposite of what is happening at equilibrium position is what is happening at the extreme end. Now, examples of bodies undergoing simple harmonic motion are, for instance, if you tie a stone with a string or rope and you whirl it circularly, and in such a way that the stone moves with a constant velocity v, the mass of the stone is m. Now, that condition of motion in circular way is an example of a simple harmonic motion, because the movement is periodic and the timing of the movement is also what? Periodic. So therefore, one example of a body undergoing simple harmonic motion is a body that is in circular motion. Another example is the oscillating loaded test tube. When you load a test tube with lead shot and you place the test tube vertically in water and you compress the test tube, you observe that the test will be moving up and down. That type of motion is oscillatory. We say it is vibratory, and it's an example of simple harmonic motion. Another example of simple harmonic motion is the oscillation of pendulum bob. The toe throw movement of the pendulum bob is an example of what? Simple harmonic motion. Another example of a body undergoing simple harmonic motion is when a spring is being vibrated. Like for instance, when the spring is loaded and the load is compressed and released, the spring will be moving up and down. That's an example of a body undergoing simple harmonic motion. Now, let us make reference to a body undergoing circular motion. There are fundamental formulae that are related to calculating parameters concerning body undergoing circular motion. And in my subsequent classes, I will show the proof of each of these fundamentals. But for now, I want us to have an idea of the relations that are related to calculating parameters concerning body undergoing simple harmonic motion. The first one is called angular velocity. Angular velocity is defined as the angular distance over time taken, whereas the particular angular distance is measured in radian and the time taken is measured in seconds. Like for instance, look at this circle down. The position of the radius is at this particular place when this angle is 0, when the displacement, angular displacement is 0. When it is shifted to the new position, there is a particular value of that angle, and it takes time t for this to occur. So the that kind of movement is defined as angular what? Velocity. So that angular velocity is theta over what? Time. But when the body has gone through a complete rotation, that is one revolution or one full cycle, the angular distance cover is taken as 2 pi radian, and the time taken at this period is called period. And then the frequency of rotation is related, the frequency f of rotation is related to the period. Frequency is the inverse,